All right, now this lesson, we're going to take a look at what happens when you switch the angles in a triangle for the sines and cosines. Now, we'll start with the A's here. So if we're down here at A, we're right next to 12, so that's the adjacent. All the way through to the other side is the opposite. And then across from the box is a hypotenuse. So for the sine, sine is opposite over hypotenuse. So 5 over 13. Cosine is adjacent over hypotenuse. So 12 over 13. Now remember, when you label the opposite and adjacent, it depends on where you're at in the triangle. So now if I switch to B, if we're standing here now we're right next to 5. So now that's the adjacent. And from B, I'd have to go all the way through to the other side. 12 is now the opposite. So when you switch angles, the opposites and the adjacent swap. So cosine B is 5 over 13. And sine, opposite over hypotenuse, 12 over 13. So look, and the reason why I had cosine on top here is those are the same. And cosine of A is equal to sine of B. So when you swap angles in the triangle, again, not the 90. We don't ever do trig from the 90-degree angles. Your sine and cosine swap values because your opposites and your adjacents swap. So sine of one angle is equal to the cosine of the other angle, and vice versa. Now, if we take a look for a more mathematical explanation here versus just talking about how they swap, the three angles of a triangle always add up to 180. And we've talked about that a lot. So the three angles of a triangle always add up to 180. This is 90. So for A and B, so we got 180 total, that's a 90, which means there's 90 left. A and B split the 90 degrees left. After you take the right angle out, there's 90 degrees left for those to split. So if two angles add up to 90, it's been since I think like the first week of school, since the lesson on this, we talked about it occasionally, but two angles that add up to 90 are complementary. So since when we swap angles, we're doing complementary angles, and you get equal outputs here, sine and cosine are complement functions, or cofunctions for short. And it says it right in the name. They both are sine. One of them's got a co in front. complement sine. Really what this is sine, and it's complement sine. So when you look at cofunctions, the outputs are equal. Right here. Goes back to right here. Sine of A, its cofunction, cosine of B. 5 over 13, 5 over 13. Same thing down here. Cosine A, 12 over 13. Its cofunction, 12 over 13. So the outputs are equal. The angles, like we said, are complementary. So that means they add to 90 degrees. So the outputs, like the fractions up here, or I'll show you in a second the decimals on the calculator. The angles themselves add up to 90. So let's take a look here. Oh, we still got some up there. Now I'll just pick a number at random, 20. Watch, sine of 20. So there's our output. Its cofunction then, 90 minus 20 is 70. 70 plus 20 is 90. Cosine 70. This is its cofunction. The angles are complementary, meaning they add up to 90. 70 plus 20 is 90. And watch what the outputs are. They are the same. All right. So which equation is always true? Sine of A and sine of B? No, these are different, so that won't work. Cosine A, cosine B, same thing. We never talked about that. Cosine C, we never do the trig stuff with the 90s. Look, sine of A, when we swap angles, if we swap cofunctions, you get equal outputs. So which statement must be true here? Same, and like these are just all the questions they've ever asked about this on this Regents, which is like 7 or 8 years old now. So sine of A, cosine of B, again, these are cofunctions, and we swap angles, you get equal outputs. That one's the correct answer. Tangent is not part of this lesson. Tangent does have a cofunction called cotangent, but you don't deal with that unless you take Algebra 2, well, trig, next year. So all those are out. In triangle ABC, complement. Oh, okay. Complement angles, complement functions, cofunctions. If we switch from sine to cosine to get equal outputs, complementary angles. There you go. Which expression is equivalent to sine? Okay. So if I switch from sine to cosine and I want to keep an equal output, an equivalent output, I need to take the complement. Complementary angles add up to 90. So if one is x, the other is 90 minus x. Just like say we had 10. 90 minus 10 is 80. 10 plus 80 gets you back to 90. So there's that one. The expression sine of 57 is equal to, oh, okay, so I got to switch functions here. Tangent isn't part of this cofunction stuff. 90 minus 57, hey, just like we did up there with x, it's 33. If I take the complement, switch to sine's cofunction, cosine. So number 6, if cosine B is 5 over 13, which one also equals 5 over 13. So the outputs stay the same. I got to do the cofunction. So I switch from cosine to sine, and I have to take the complementary angle right there. I have to swap angles. And then, I mean, this is just the same thing over and over again on the front. Cofunction of sine B, cosine A. Switch the function, take the complement. Then again, cosine A equals radical 21 over 5. Well, we don't see anything like that, but I mean, this isn't that bad. So cosine A switches to sine B, switch the cofunctions, complement angles. Hey, there we go. Same outputs, like I said on the notes, on the equal outputs. Okay, so now we actually have to do some math here. I mean, like writing some work down. We switch from sine to cosine, they're cofunctions. So these angles are complementary angles. So they add up, plus that one, to 90. 4 plus 46 is 50. Subtract 50, divide by 2, 20. Same idea for 10. We have our cofunctions, so these must be complementary angles. So they add up to 90. 4 plus 3, 7x. Well, minus 13, we get 77. X is 11, but be real careful. It says, what is the number of degrees in the measure of the smaller angle? 11 is x. It's not the answer here. I mean, we need it to get the answer, but be careful on these Regents questions. The first thing we get is 11, and that's the first answer. So just be careful. We got to plug in 4 times 11. That one's 44. We plug 11 in here. 33 plus 13 is 46. 44 is smaller. 46 isn't a choice anyway. 11, again, these add up to 90. Negative 1 plus 3 is 2x. I'm going to minus 40. I get 50. Half of 50, 25. Same idea on the next one. Seven minus 7 is gone. Divide by 6, 50. No trick here, just wanted x. All right, cofunctions. Take the complement. 90 minus 73, 17. Explain your answer. For cofunctions, take the complement. Now, 14, be really, really careful. Angles this time aren't the x and the numbers. Sine of A is the angle. Its output has that x. Cosine B, its output is that. These are cofunctions, and if we look back at the brief notes I gave you, it says the outputs are equal. So when they switch to outputs, just set them equal instead of add up to 90. I'm going to minus 2x. Add the 0.7, you get 0.8. Divide by 2, 0.4. Explain your answer. I don't have room to write that down. It's cofunctions have equal outputs. Explain why. Cosine x equals sine of 90 minus x. Cofunctions, the angles are complementary. 90 minus x is the complement of x. 16, if sine of A increases, what does cosine of B do? Well, they are cofunctions, and I guess they mean they're going to change the triangle or something here, but whatever. So they have equal outputs, like we said on the notes. So if one increases, the other increases. That's the explanation. So Alex said sine of 28 is opposite HJ over hypotenuse 20. Marlene said cosine of 62 is HJ adjacent over hypotenuse 20. They're both correct. Explain why. Cofunctions. Those are cofunctions. So they have equal output. Cofunctions have equal output. We also practiced a few word problems using this. Now, basically, well, not the cofunctions, just regular trig. A carpenter leans an extension ladder against a house to reach the bottom of a window 30 feet above the ground. So we got our triangle, that's 30 feet. As shown in the diagram below, the ladder makes a 70-degree angle with the ground. To the nearest foot, determine and state the length of the ladder. So basically for these word problems, you got to find where to put the numbers they give you, then figure out where to put the x. So if we want to find the length of the ladder is what leans up diagonally, so there's x. Here's our angle, 30 is opposite. X is the hypotenuse, so sine of 70 equals 30 over x. Well, we got to multiply by x first, then divide by sine of 70. So 30 divided by sine of 70. And this one says to the nearest foot, 31.9 becomes 32 feet. As shown in the diagram below, a ladder 5 feet long leans against the wall and makes an angle of 65 degrees with the ground. Find to the nearest tenth of a foot the distance from the wall to the base of the ladder. Well, they got most of this labeled for us here already. So we didn't know where to put the 65. They did it for us. The ladder's 5 feet long. There we go. Now, the distance from the wall to the base of the ladder. The base of the ladder is down here. So we're looking for the bottom of the triangle. The distance from the wall to the base of the ladder, the bottom. That's the hypotenuse. We're right next to x, so that is the adjacent. Cosine, so ca, toa. So cosine is a and h. Cosine is 65 degrees equals x over 5. Multiply by 5. Oops, geez, I forgot to type cosine in. So 5 times cosine 65. This time it's the nearest tenth of a foot, 2.1. All right.